this video, we're going to have a look at expanding and factorizing simple expressions. Expanding brackets uses the distributive law. Here we have A multiplied by, in brackets, B plus C. Remembering the distributive law, all terms on the inside must be multiplied by the terms on the outside. Therefore, we have A times B plus A times C. Simplifying this, A times B, we have AB plus A times C, AC. We can also use boxes or the area model to help with expanding. Here we have A, one term outside the brackets, and B plus C. Thinking about what the area would be of the first box, A times B is AB, and the area of the second box, A times C, like length times width, AC. Adding these together, we have AB plus AC. Let's now have a look at two examples. 3 multiplied, in brackets, by 2x plus 5. Using the distributive law, 3 times 2x plus 3 times 5. Simplifying, we have 3 times 2x, 6x, plus 3 times 5, 15. Again, we'll show this using the area model. 3 is on the outside of the brackets, and 2x and 5 are the two terms inside the brackets. The area of the first box, 3 times 2x, and the area of the second, and putting them together we get the same answer. Let's do one more example on expanding. A times 4a, and this time we have a minus. We could think of this as plus a times negative 3, or you could just simply write minus a times 3, knowing that when we add a negative it's the same as subtracting. I'll stick with adding the negative. Here we have a times 4a, 4a squared. Now a times negative 3a is negative 3a. We could write it as plus negative 3, but it's simpler to write 4a squared minus 3. Sorry, a. Again, using the area model, the width is a, our terms 4a and negative 3, the area of the first box 4a squared, the area of the second is negative 3a, and then adding them together we get 4a squared minus 3a. The reverse process of expanding is factorizing. If we look at our first example, we see two terms, 6x and 15. The highest common factor of these two terms is 3. This goes on the outside of the bracket. We then can divide each term by the highest common factor to determine what goes inside the bracket. Or you can think 3 times what will give 6x, and 3 times what will give 15. Let's try with 3 examples. Here we have 6y minus 2. The highest common factor of the terms 6y and minus 2 is 2. It goes on the outside of the brackets. Now we can divide each term. 6y divided by 2 is 3y, or just think 2 times what will give us 6y, and we have 3y. Here we have a minus, so we'll put the minus in, and 2 times what will give us negative 2. Here I've already put the minus in, so it's 1. To check, we just can re-expand. 2 times 3y is 6y, and 2 times negative 1 is negative 2. Let's go to our second example. 5a squared b plus 10ab. First of all, look at the coefficients, the numbers, 5 and 10. The highest common factor of the numbers is 5. Then we look at what pronumerals they have in common. Well, they both have at least one a, and they both have at least one b. The highest common factor in this case is 5ab. Again, we can do a division or simply think 5ab times what will give 5a squared b, that is a, and 5ab times what will give 10ab, that is simply 2. To check again, we would expand. In our last case, 4x squared minus 2x. Here, the highest common factor is 2x. 2x times what will give 4x squared? That is 2x times 2x will give 4x squared. And we've got a negative, and it's negative 2x, so we just need 1 there. Checking by expanding, 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. And there you have some examples of simple expressions, expanding and factorizing.